Hi there, welcome to the second video in the differentiation topic at higher. Today we're going to look at what happens when you have to differentiate involving x in the denominator of the fraction or x that's being rooted. Okay, so the square roots, cube roots, different things like that. Okay, so firstly, looking at learning attention success criteria for this video, we want to be able to differentiate terms involving x to the power n, denominator, and roots. Okay, so three things we want to be able to do. Firstly, rearrange expressions so that all terms are written in the form x to the power n with a power, and then differentiate these terms successfully like we did in the last video, multiplying by the power and decreasing that power by 1. And lastly, we're going to look at a couple of examples where a multiplier is involved at the start of an expression. Okay, so firstly here, what we're going to look at is differentiating variables. If you are differentiating variables, the x's, whatever letter it is, have to be on the numerator and have to be written in index form. Okay, and what that means is they cannot look like this. Okay, you can't have 1 over x squared. Okay, that's got to come to the top of the fraction. Okay, and remember when they come to the top of the fraction, powers from National 5, we know that powers turn into a negative. Okay, so x squared moves to the top. That means that it's x to the power negative 2. The other thing we need to be careful of is we can't have any roots in there. Okay, we can't have square roots, we can't have cube roots, we can't have anything with that rational sign there. Okay, and what we'll do is we'll look at an example like this where you've got the cubed root of x squared. Again from National 5, and this is something that people do tend to forget moving from National 5 to higher, is if you want to rewrite this, okay, remember that the roots, the power of the root goes to the bottom of the fraction. Okay, flower power, if you remember like that, the roots are on the bottom of your power. Okay, so these are the two things we're going to need to be confident with before we move on to this, before we can differentiate. Okay, so that might be a good place to start for your notes, and then into here for some examples. Okay, so we've got a bit of a problem here differentiating because the x cubed is on the bottom of the fraction. So before we can differentiate, so still working with f of x, we're going to rewrite this with the x moved up to the top. Okay, and when you move that x up to the top, the power becomes negative. So we're going to be differentiating x to the power negative 3. Okay, then ready to differentiate, I make sure my notation's good. So I'm going to do my differential. My power comes down, so it becomes negative 3x to the power negative 4. Okay, and then just as a wee bonus, I can rearrange here. Okay, you're not always going to get marks for it, but it does help if you are going to substitute into your differential. The x to the power negative 4 goes back down to the bottom, becomes x to the power 4. Okay, so really we want to be concentrating on this top bit, but once you get comfortable, you want to also be moving it back into usable form. Okay, in B here, we're doing f of x is equal to root x. Okay, we cannot differentiate that as it stands because we've got the root there. So we need to rewrite f of x is equal to root x in the form, in index form with a power. Okay, so this is a square root. So the 2 is going to go to the bottom of my power, the fraction in the power. Okay, and then we're ready to differentiate. Okay, so f dash x equals, that half comes down in front, then it's x to the power negative a half. Okay, and again, we've just got 1/2 to take away a whole. So we take away 2/2, and that takes me down to negative 1 over 2. This should become second nature very quickly working a differentiation. Okay, and then again, we can rearrange it. Negative is going to send the power, the x back down to the bottom, and because it's power of a half, it's going to be root x. Okay, again, up to that line is where we want to be concentrating on, rearranging it first, then differentiating. But if you can rearrange at the end as well, that will help you in the coming topics. Okay, so a couple more examples. If we've got C here, again, we've got a couple of issues here. One, there's a root involved, and secondly, that power's on the bottom, that x to the power's on the bottom. Okay, so firstly, because it's a cubed root, this is going to end up being x to the power of a third, and then when it comes to the top line, it turns negative, so it's x to the power negative 1 over 3. Okay, and then your differential, f dash x, the negative 1/3 is going to come down to the front, x, and taking away a whole, or taking away one, you're taking away 3/3 in total, so that's going to end up down at negative 4/3. Okay, and again, we'll keep rearranging. The negative power is going to send it to the bottom of the fraction. Okay, and then because the 3 is on the bottom of the fraction, that's cubed root of x to the power 4. Okay, for d here, we are rearranging this, the 4th root of x to the power 5. So it's the 4th root we've got. So roots are on the bottom, and then we're ready to differentiate. Okay, so it's f dash x. The 5/4 come down. Your x. We decrease the power by 1, so taking away 4/4 altogether. Okay, take it down to 1/4. Okay, and rearranging at the end there, it'll be 5/4, the 4th root of x to the power 1, or just x. Okay, so that there is working with powers, working with negative, working with x's on the bottom, and how to differentiate there. So we need to get rid of any x's on the bottom, move them to the top, and we need to get rid of any roots as well. Okay, last bit of this video is going to be looking at products as well. Okay, if you have f of x equal to ax to the power n, if you're multiplying at the start, when you move the power down, it's just going to multiply by whatever number's there. Okay, so f of x equal to 5x to the power 4. That means f dash x, the 4 is going to come down and multiply by 5, so that'll be 20, and then x to the power 3. Okay, in part B here, we cannot have that root x. It's got to be 6x to the power of a half. And then now that roots are gone, we can differentiate. Okay, so the half comes down, multiplies by the 6 to give you 3. And then it'll be x, decrease the power by 1, it'll go down to negative a half. Okay, and that means that 3, the negative power sends it down to the bottom, and the power of half will turn into root. Okay, last couple of examples, and then we'll be done. Okay, here we've got f of x equals 6 over x squared. So bringing that x squared to the top is going to make it a negative power. So 6x to the negative 2, and now we're ready to differentiate. Okay, so f dash x, negative 2 times 6 is negative 12. Okay, so in negative 12, x, decrease your power by 1 makes it negative 3. Okay, and then that x to the power negative 3, that negative power means it should be on the bottom. Now that power is only connected to the x, so only the x moves down to the bottom. So it's minus 12 over x cubed. Okay, and last one here, f of x equal to 1 over 5x to the power 2/3. Okay, firstly, x in the bottom, no good, needs to come to the top. Okay, and when it comes to the top, that power is only connected to the x. Okay, so only the x moves, the 5 stays on the bottom, and it's x to the power minus 2 or 3. Okay, which means f dash x is going to be minus 2/3 times 1/5. Okay, so remember multiplying fractions, multiply the tops, multiply the bottoms. It's going to be negative overall. 1 times 2 is 2, 5 times 3 is 15. And then x, decrease it by 1, goes down to minus 5 over 3. Okay, and then just rearranging at the end, it's going to be negative 2, negative power is going to send it back to the bottom. Okay, and because the 3 is on the bottom of the fraction, it's going to be the cubed root of x to the power 5. Okay, quite a long video there, apologies for that, but just looking at the learning intention success criteria, we should be able to rearrange expressions so that all terms are written in the form x to the power n. Okay, so that means moving things from the bottom to the top so that the x's are on the numerator, and also getting rid of roots involved there. We want to be able to differentiate these just like we have been before. Okay, so multiplying by the power and decrease the power by 1, and we also want to be differentiating terms that have a number at the front. Okay, thanks for your time. Cheers.